Hi everyone. Today again we have come to continue from where we stopped. We are still under electrolysis. Electrolysis, we have done something on electrolysis of acidified water. We have also done something on electrolysis of copper 2 tetraoxosulfate 6 using carbon or platinum electrodes, and we also did it using copper electrode. And today we are going to move on to electrolysis of sodium chloride solution using carbon electrodes. Now, the electrolysis of concentrated NaCl, sometimes they can say brine. It means the same. Electrolysis of brine, B-R-I-N-E. Electrolysis of brine, it means the same thing with concentrated NaCl. Now let's see if we want to do that, pass electric current into a solution containing NaCl, concentrated NaCl. So when you dissolve it in water, you have something that looks like this. So I have connected my electric source into the solution. This is my negative and plus. This is anode, don't forget. And this is cathode. Don't also forget. Cathode is negative, anode is positive. The solution contains NaCl and H2O. You have cation to be Na plus here. Here will be H plus. Cl will be your anion. Here you have what? OH minus. Now, unlike charges will do what? Attract. So at the anode, you have these four ions present in the solution. So at the anode, what will happen at the anode is that since anode is positive, the two negative will move down there. Remember, the solution, when they move down there, you consider what? The position and the position on electrochemical series and the concentration. Now, since we are using carbon is inert electrode, it will not influence the discharge of ion. So I will shift carbon aside. I will only consider what? Position of those ions in electrochemical series and the concentration. Now, when two of them march down to where I have the anode, which there must be these two negative coming to the anode because anode is positive. When they come, the concentration, since they are not far apart, go to your electrochemical series that I gave you, check their positions. They are not far. When they are not far, you leave position and concentrate on concentration. Now they are close by, so we will now be considering what? Concentration. Which one has higher concentration? The solution says concentrated sodium chloride. So chloride ion is of higher concentration. So Cl minus will come here from this solution, donate the excess electron that it has. The electron will flow in this direction and enters here. So, and itself will turn to Cl plus E minus. Now, since it is diatomic molecule and it's a gas, it will not remain there. Another one will do same, and both of them will do what? Pair up to form Cl2. It's a gas and it will bubble out. It will not remain inside the solution. You see bubbles going up here out of the solution. That bubbles Those bubbles are what? Chlorine gas. They will leave the solution. Now, at the cathode, the remaining two, cathode is negative, so this plus and this plus will move down there, they will migrate there, and then they will also contest on who will be discharged in preference to the other. Now, you check the position again on that series. They are very far apart. They are not close by. So we will not consider what? Concentration. Instead, we will consider what? The position. Sodium is far up while hydrogen ion is far down. So the law there says that the one below will be discharged in preference to the one above. That means that hydrogen will be discharged. So hydrogen ion that are coming here will collect those electrons that are running down from this side. They will collect itself, or the electron there, one electron, because it is in need of one electron. And after collecting the electron, it will not be in the solution again. It will turn to an atom of hydrogen is unstable, so it will also look for another atom and pair up, since it is what? Diatomic molecule. So you have H plus H to give you H2, and that H2 is a gas and it will bubble out. You also have gas going out, bubbles here. So at the two electrodes you have bubbles of gases. One at the anode is what? Chlorine. The other one at the cathode is what? Hydrogen gas. So the two gases will leave the solution. Now, having known that this one is leaving the solution, we have known what happens here. What happens here? We have written the equations. Now let's see what happens to the electrolytes after sometimes. This one is leaving the solution. This one is also leaving the solution. And this is left. Therefore, the solution will now turn gradually to NaOH. Remember, we started with what? NaCl, and we are gradually getting what? NaOH. This is salt. This is salt, sodium chloride solution, salt, sodium chloride salt. And this is a base. Sodium hydroxide is a base. You are gradually producing a base from salt. So that is what the reaction is designed for. Enjoy yourself. I believe the lesson is making you happy. If it is true, you can subscribe, watch more videos, and keep on following the channel. See you some other time.